Yeah, warm good afternoon, class. Previously, we have seen what is iron carbon phase diagram, what is the base of studying this iron carbon phase diagram, why it is so important, and we have split this iron carbon phase diagram into small areas, and we have seen what is the major phases, what is the white percentage of carbon, what is pure, what is allotropic formation, allotropic transformation, and what is the ferrous carbon alloy transformation, right? So today we are going to see. Apart from this, we have another most important thing, which is known as invariant reactions. Okay, there are three invariant reactions that occurs in this iron carbon phase diagram. For any phase diagram, if a combination of two or three alloys, for combination of two alloys, we have a binary phase diagram. For combination of three alloys, we have ternary phase diagrams. In this all these phase diagrams, we can see some reactions taking place. Okay, some reactions taking place. For particularly in this iron carbon phase diagram, there are three invariant reactions. One is peritectic reaction occurs at 1495 degrees Celsius at 0.1% of carbon. Here eutectic reaction is at 1147 degrees Celsius at 4.3% of carbon. Eutector reaction at 730 degrees Celsius at 0.8% of carbon. We'll see deeper. Okay, the first one is peritectic reaction. Okay, keep it in mind, if a reaction is ending with tick, it is always stays at the higher side. If it is toid, TOID, it always lower the lower side, right? So for this first peritectic reaction, in short, we can say if a solid one, it is added with a liquid, it forms on cooling at the top, on cooling upon heating. Okay, this is the side looks like this. Okay, if it form a solid 2, then it is a peritectic reaction. On any phase diagram, if a solid and a liquid forms a different solid with the different properties, it is known as peritectic reaction. But in this iron carbon diagram, it is found at temperature of 1492 degrees Celsius, right? 1492 degrees Celsius. Here it is delta N is 0.1%, where we have seen is in the in the previous slides, and it is the liquid is at 0.5% of carbon at this area, 0.5% of carbon. So here the austenite is 0.18% of austenite with the carbon. Austenite is formed at this particular reaction, right? So when we come to the next reaction, it is known as eutectic reaction. Here there's a slight difference, important thing to be added. Means this eutectic reaction completely occurs at the cast iron part, right? First, that peritectic reaction, what we seen in the previous slide, it occurs at the steel part, but this occurs at the cast iron part. Here, if a liquid, okay, upon heating on cooling, again on heating at the same type, it's here you can see if it is giving two different solids. If it is giving two different solids, then that reaction is known as eutectic reaction. In this iron carbon diagram, it occurs at 1400 degrees Celsius, as here it is 1130 degrees Celsius, 130 degrees Celsius. And here this two solids is nothing but the austenite and cementite. This complete formation, this combination of austenite and cementite is known as ledeburite, right? This two components which is joined together, it is known as ledeburite. Okay, so it is this particular mixture is known as ledeburite mixture, right? And it is formed at the eutectic point, so it is known as eutectoid mixture, right? Here the liquid is at 4.3. This line is 4.3 per weight percentage of carbon, so it is 4.3. And the cementite is formed 6.67, and austenite it is 2.2 weight percentage of carbon, right? So now when we comes to the next reaction, it is known as eutectoid reaction. It occurs at 720 degrees Celsius in this iron carbon diagram. In short, if you can say, if a solid one upon this heating and cooling process, if it is giving, okay, upon cooling, if it is giving new solids S2 and S3 on cooling, on heating, if these two solids on giving this S1, okay, then that reaction is known as eutectoid reaction. But in this iron carbon diagram, it is known as, it is found in the steel part, right? Okay, there are three reactions in this. First is peritectic reaction. It also occurs in the steel area. The eutectic reaction is only the reaction that occurs in the cast iron area. Here eutectoid reaction occurs at the steel area, as we discussed. Okay, Here you can see there are, as I discussed, I said two solids, right? S1 and S2. So the two solids are nothing but the ferrite and cementite. So this ferrite and cementite is known as pearlite mixture. So it is a eutectoid mixture, which because it occurs at the eutectoid point. So this eutectoid mixture is nothing but the formation, is nothing but the ferrite and cementite. Okay. So as we in summary, we can say we have seen the major phases. We can see you can see the carbon content. We have seen the invariant reaction. So these all combined together forms the iron carbon phase diagram, which is the most important diagram, which is the base of all ferrous materials dealing industries. Okay, in our world, in this world, the cast iron is ferrous materials dealing industries are running based upon this iron carbon phase diagram. Okay, so that's all for today. Thank you. Have a great day.